Hello and welcome to the next video. In this video, we will going to cover the one interesting topic that is relating to the uh, classification and the regression problems. So the topic is related to the decision tree. So what actually the decision tree is, as the name suggests, it is a kind of tree which has some nodes, some leaf, or some branch, or some root. So what actually the purpose of decision tree is, and what are the terms that people mostly use while discussing a decision tree? So which approach we used for calculating the things? So in this today topic, we are going to cover the basic concepts of all these. So let's start with the decision tree. The as we know, the machine learning is totally depends on the algorithm. The algorithm belong to some statistical problems or some other problem. So as the decision tree is an algorithm belong to supervised machine learning, and it can be implemented for the regression or the classification problem. So we will cover that what actually the regression and classification are, but we have a little bit discussed about the classification in our previous video. So the commonly it works like a conditional statement. If you guys are very familiar with the programming, so there is some conditional structure like suppose we are going to get the value. Suppose we are going to judge the age of any person, so we check that if the age is greater than suppose 30, or then we're going to print that something if if else, or might be we use a simple else. So we use in that way the decision tree. So the some basic terms are relating to the decision tree are the root node. As name suggests, root is the main or the starting point where the things belong from. So what actually the root node is the main or starting attribute which divides the data into different sets. The parent node, the parent thing, the starting point is called a root node. And what actually the branch is, the another discussion is branch. A branch describes the connection between nodes or subsection of the decision tree. And the another concept is comes and that related to the splitting. Splitting or divide a node into more subnode. So we will cover in our upcoming lesson. So what actually the splitting all these stuff are, but right now consider in this way. And another is a decision node. When a subnode split into further subnode, we call those nodes decision or internal node. And the last one is a leaf or terminal node. As if we look at the tree start from the root, then there is a some branches, or then the last one is a leaf. And as it is the same for that leaf is the end of the node where it cannot be split more. And then is the one another concept that is a pruning. uh, so this is about when we are going to predict something. So there is a one concept that mostly people face while calculating the things: overfitting or underfitting. So to overcome all that, mostly for the overfitting, we use a pruning, removing a subnode from a tree. So we will learn in when we start working on the development phase. And the approach people use to select the which feature is the most important, which are not. Mostly people use it a top down greedy approach, and the best selection entropy measure mixed disorder column. So and there is a one concept. Suppose we have a data set, right? I have this data set actually. Suppose we have this data set. This is a data set that I have take from somewhere, and took from somewhere. Suppose here is the days, like the 14 days, and these are the columns or attributes: outlook, temperature, humidity, wind, and play. from the person that are not too much familiar with what actually these means are. So this is simple table which has the header and some value. So what we are going to, I mean, express, or what we are going to achieve. So suppose we want to achieve, if you can see that here there is no meaningful data for to what actually we can play, achieve that. But suppose we are going to predict the tennis, or predict the can we play the tennis today or not. And these are the some attributes: outlook, temperature, humidity, and wind. How we know that which field, which column, which attribute should be the root node? So to check all that functionality, by the way, there is no need to worry about that. The algorithm that we used in programming, that algorithm automatically decide all the things. But for the just learning purposes, like how the algorithm is working behind the scene, so that are just a concept for that. Otherwise, there is a no hard coded rules like we have to follow this entropy or all this formula. That is all automatically handled by the algorithm. So these are the four column or four attribute: outlook, temperature, humid, and wind. So which should be the root node? So to check that which should be the root node, we use a entropy. What actually the entropy is? Entropy is nothing. It's a disorder or mixed of columns value. Suppose here is the outlook, and which has some sunny outlook, rainy, overcast, and a temperature have a hot, wind and mild, like that, humidity high, normal, wind weak, strong, blah blah, all this stuff. So the entropy is just a measurement of disorderness. So how we can calculate the entropy? So there is some one basic formula: E of S, and then sigma C or I is equal to 1, and minus P I log 2 P2 Pi, sorry. So to calculate the entropy with the data set S means the data set. There is the one concept in the machine learning: data set. Data set is nothing. It could be your anything. It could be your Excel file. It could be your database. It could be your collection of images. Everything. It can be anything. So the calculate the entropy with the dataset S. In the case of feature, calculate entropy for all values, average information entropy for current attribute, calculate the gain for the current attribute, select the high gain attribute, repeat until no more split. So this is the just uh, the overflow, or the we call it a algorithm, how the entropy work. It's calculate the entropy, the whole data set with the data set, and it calculates the entropy for each value. Suppose this one, the sunny in the outlook, and then the overcast, then the rainy, and so on, and then select the highest attribute. So at the moment this is a bit not clear, bit confused to what actually this we are going here. So just consider this a data set, and it has 14 rows, 5 P. P mean positive. Yes, P mean positive. Consider it here is the yes, right? The yes is the P, and no is the negative, which mean no. If we count that, this is the target, our target value. By the way, this is our a binary classification problem, true or false. But it could be a multi classification problem, like we have a more than one target values, and the total value is 12 14. 9 is a positive, 5 is the negative. So here is a simple formula. This is formula: entropy of S C, or add that. So let's start with the if we just split the formula, it will become like this: entropy is equal to minus P mean the attribute, then the divide by P plus N, and then the log 2 P divided by P plus N, and then multiply with the previous one minus 1, and then minus n and the number of the value, and the p plus n and the log 2 n the number and the p2. This is the basic formula. So let's start with the sunny, with the outlook. So here is the outlook, and if we count the sunny, how many sunnies we have? We have total sunny 1 2 3 4 5. We have 5 sunny, and how many are the negative and how many are the positive? The sunny first one is a no, the first second one no, and third one is a no, and sunny one is a yes, sunny two is a yes. So that's why minus 2 divide by how many total sunnies are? These are fives. Divide by fives log, then the 2, this one, this value p, 2 divide by 5, and then across, I mean multiply, then minus total number of no, and what are the no? No mean the negative, and you can see that we have how many negative we have? 1 2 and 3. So here is 3 divided by 5 log, and then 3 divided by 5, and when we this calculate, it will comes to 0. 0.7 0 0.971. And there is a one thing that is related to the overcast. If we come to the overcast, it is overcast 1, overcast 2, overcast 3, overcast 4. The first one is a yes, the second one is a yes, the fourth one is a yes, and the uh, sorry, third one is yes, and the fourth one is yes. So meaning that we have all the positive number, no negative number, so that's why it always becomes a 0. And in the case of, suppose we have a value for like overcast, we have a 2 value positive, 2 negative, then at that becomes a 1. So that's why we don't need to calculate all that. So let's come to the in case of rainy. Here is the outlook, and the attribute name is rainy. 1 2 3 4 5. We have 5 rainy, and how many are the positive? The first one, the second one, and third one. So we have 3 positive value for the rainy case. How many total are? These are the 5, then the log, and the total, I mean the positive total divided by total occurrence of the rainy, and then the log minus the same like the above formula, so it becomes a 0.971. So now we can see that suppose we have a data 4 points in our data set, 5 belong to the negative and 5 belong to the positive. So we would say that p plus 9 and p plus 9 divided by 14 and p plus y. This is just a basic information for that. Now we know that our highest entropy is 971. If we have a suppose something else like 0.63, so that will be another entropy for the another attribute. But fortunately, our both data set, our both columns, sunny, I mean the attribute of the column has the sunny and rainy has the same value, 0.971. When all these comes, so now here is the value of the outlook for the total. 3 plus 2, that is in the case of sunny, 3 plus 2. Now we can know that there is a total value of 3 plus 2 divided by 9 plus 5, because total value, how many total value we have? We have over value, total value 9 positive, 5 negative. So the 9 plus 5 and 3 plus 2, that is the total value of our this one, the sunny, and the 2 multiply by our value of the entropy. So that is across 0.971 plus The another value is belong to 2.2 plus 3, and the total value of uh, 9 plus 7, 9 plus 5, and then the same. So in simple wording, the outlook's value is become to a 0.693. So this is the value for the outlook, and we will calculate the same value for the temperature. So with the same formula, so it will also return the same value. And I mean, not the same value, definitely will be the value would be the same, but the formula will be the like this one, the same. So it should return a something different, and then you have to calculate the value for the temperature, and that will be something different. And in that case, there is a humidity, the same formula, the same value for the high and the humidity, and the plus and negative, all that stuff, and it will become to a same value over here. So at the end, you will guys find some average calculation for every attribute, and then which attribute should be the our parent attribute. So the simple answer is that the attribute which has the highest value, in simple wording, highest value, that would be our root node. Because I did not calculate all that over here in my word file, but all these other column does have a lowest value, so that's why I did not mention all that. So the outlook is a highest value for here. So the outlook is our parent node. So the another concept is comes over here in the machine learning, I mean in the decision tree, that is called information gain. As we know, we are in the some kind of purity. Firstly, that was impurity. Now we are coming to forward to the some kind of our analysis, some kind of our answer. So for that, there is a concept information gain. How much entropy we have removed? Like we have removed one entropy or two entropy, because we are at least familiar that we have at least have a guarantee that the outlook and its all the column have different value. And now we are in this position like we are has in a maturity that the outlook is our highest value, and that is our root node. So the information gain is give us a how many I mean entropy we have removed. So the information gain of 1 would be the best value, possible value, whereas the value of 0 mean no uncertainty or entropy has been removed. So to calculate the entropy, calculate the information gain, the formula is simple. Gain is equal to entropy of S, the total data set, minus I or attribute, or the full formula, the simple one. Mostly people use this. This is another formula. For IG information gain, T, and T is actually the target our column, and A is a variable column we are testing, and the entropy of T, the data set, minus sigma V and A, and the another one is a TV and divided by T, and dot entropy TV, the same like that. So it will become a like that. And the some concept like what is the meaning of T and A V and sigma and some operator. So the T mean a target, our column, the target values for the, in our case our target column is a play, so that is our target column. And the A is a variable column we are testing. The variable column in every column that we are testing, every column, suppose the outlook, temperature, humidity, or wind. So this will comes over here. V is the each value in our column or in our outlook. So suppose here we can see that outlook, when we calculate this, when we apply this formula, we will get the information gain. And with this in formula, we will get that the outlook is a 0.247, the temperature is a 0.029, and the humidity is a 0.152, and the wind is a 0.048. So as I said, we will get that value that has a highest gain. So our highest gain is a 0.25. So that's why this is our uh, parent node, and this is our I mean the information that we have gained as much as we can. So the root node is outlook. So what would be the decision tree? The This would be our final decision tree, the outlook, like the parent node. And the sunny, in the case of sunny, we have a humidity, and in the humidity that could be a high or normal. And as the overcast, in the overcast we know that overcast is a zero, so that's why it is the starting node, and there is that is our terminal or leaf node. And then the rain, again, in the case of rain, we can know that the rain has a 0.79. So and the another node is the rain, and the rain the has a wind, and the wind has a weak or strong, and then this would be a our decision tree. This is just a general theory, so no need to worry about that. We are not going to give any kind of paper test or result, but this is consider just a basic overview how the decision tree work, what actually decision tree are. So in the simple wording, the result, if the result is a positive, we lowered entropy with our split. The higher the result is, the more we are lower entropy. So this is just concept. So in our next video we are going to load a data set in the Python, and we will try to apply all the logic, all the terms that we have used, where we are splitting the data, where we are presenting the data, and what is the entropy, all that. So in our next video we will do this in a practical way.